In this video, we'll be talking about EKGs, also known as ECGs, electrocardiograms. You're looking at a sample EKG down here. The EKG is a composite tracing of all electrical activity of the heart. It's not an action potential. It's very important to remember, not an action potential. EKGs are useful for detecting irregularities in the heartbeat, called arrhythmias. Arrhythmias can indicate heart defects or even a heart attack. Electrical activity of the heart is detected by placing electrodes at various points on the body. In a standard EKG reading, electrodes are placed at 6 locations in the chest, plus an electrode on each limb. The information from all of these electrodes, also called leads, is all integrated to form the EKG pattern. The subject is usually asked to remain still during the EKG and maybe even to hold their breath so that the electrical activity of contracting muscles doesn't interfere with the EKG reading. A typical EKG has a recognizable pattern. You have the P wave, followed by the QRS complex, so this whole thing is the QRS complex, followed by the T wave. The spaces between these events can be informative too. You have the PR interval, which is actually measured to the beginning of the QRS segment, but it's called the PR interval. Then you have the QT interval and the ST segment. Now, let's see how these different features map to electrical conduction through the heart. The P wave represents depolarization of the atria, so the SA node firing and that depolarization wave moving through the atria. P wave abnormalities can indicate a problem with the atria, such as an abnormal enlargement of the atria. The PR interval between the P wave and the QRS complex indicates that delay of conduction at the AV node, so that pause that electrical conduction takes at the AV node. So a problem with the PR interval can indicate damage to the AV node or problem with electrical conduction through the atria. The big QRS complex represents ventricular depolarization. Atrial repolarization happens during the QRS complex as well, but basically gets swamped out by the stronger signal from the ventricles. There's just so much more myocardium getting active, being depolarized in the ventricles, than there is repolarization with the atria. Abnormalities in the QRS complex can indicate hypertrophy of either left or right ventricle. Hypertrophy just means enlargement. It can also indicate damage to the bundle branches that are supposed to conduct electricity through the ventricular myocardium. The ST segment that got between the QRS complex and the T wave, this is when the ventricular myocytes are in their plateau phase, and the ventricles are all entirely depolarized. The T wave represents ventricular repolarization. Any abnormality in the ST segment or in the T wave can indicate coronary artery disease. If you have coronary artery disease, you have impaired blood flow to the myocardium, impaired oxygen to the myocardium, and you can get disruption of these features. Myocardial infarction, heart attack, can disturb both the QRS complex and the ST segment in T wave. But looking specifically at the ST segment in the T wave can allow a cardiologist to distinguish between an old infarction, damage that might be weeks or even years old, and an acute, ongoing event that needs to be treated. Finally, after the T wave, ventricular repolarization is complete and the EKG is flat, briefly, until the atria depolarize. Ventricular fibrillation is a very dangerous situation in which depolarization of the ventricles is completely chaotic and uncoordinated. It produces a very distinctive look on an EKG. Because the contractions are completely disorganized, the ventricles can't actually pump blood. They just quiver. I've heard it described as the heart looking like a bag of worms squirming around under the epicardium. Ventricular fibrillation is common after a heart attack. This is cardiac arrest. Cardiac arrest refers to the electrical malfunction. Myocardial infarction refers to the loss of blood supply and resultant death of tissue. Ventricular fibrillation can happen in young people if they have a heart defect, either known or unknown. If you hear about a student athlete collapsing on the football field and dying, oftentimes what has happened is if they have no previous known illness, oftentimes the problem is that they had a heart defect that hadn't been found, and they went into ventricular fibrillation. It can also be caused by electric shock or by lack of oxygen. If you've heard the term defibrillator, a defibrillator is an instrument that basically delivers an electrical shock to the heart. It momentarily depolarizes the heart muscle, in essence stopping the heart in order to get it out of this fibrillation pattern. Ideally, that brief depolarization of the entire heart muscle stops the fibrillation, and when the electric shock is removed, the SA node can take over again and reestablish a normal heartbeat. If someone goes into ventricular fibrillation, treatment is necessary within 5 minutes if that person is going to survive. The heart cannot pump at all in this condition, so the brain is not getting any oxygen during ventricular fibrillation. This is why AEDs, automated external defibrillators, are so important to have around. After studying this video, you should be able to identify the features of a normal EKG and explain what's going on in the heart that generates each of these features. You also should be able to talk a little bit about ventricular fibrillation.